Hi. So let me walk through the assignments, starting with the Cipher assignment. And you were supposed to create an interface called Cipher and use that interface for both the different types of ciphers, the replacement cipher and the shift cipher. And let us look at that interface first. This is preferably how it should look, with two methods, encrypt and decrypt, and these methods should receive the text that should be encrypted or decrypted and return some text, that the encrypted text or the decrypted text. You have all, which passed the assignment, created this Cipher interface, but this interface you have not used it in the most useful way. For example, some of you have created encrypt and decrypt methods with no parameter, and some of you have created the methods without a return type, so you have made them void. And preferably they should receive a text and then return the encrypted or decrypted text. Otherwise, if you don't do it like that, those of you who created these two methods without parameters had to send the texts through the constructor of the different ciphers. And by doing that, you had to create new cipher objects for each message. And that is not necessary to do that. It is better to keep the same object and to send each new message that is to be encrypted or decrypted as parameters to these methods. And there were others who made these two methods void, used the return type void. So you made them return nothing instead of a string. And the problem with that is that you had to print the encrypted texts inside these methods. And it is better to return the encrypted message or decrypted message back to the caller of these methods. Otherwise, you could only use the ciphers in a console application and where you print the text to the console. But you will not always do that. It is much better to have the freedom to do whatever you want with the encrypted or decrypted texts. So if you just return the texts as this interface does, then you can do whatever you want with the returned messages. So this is the way the interface preferably should look like. Now, let us look at the shift cipher. It should implement the cipher interface, and I stated in the instructions that you should receive the number of positions to shift each letter in the message. That the number you should receive as an argument in the constructor. So it should look something like this. And then I have the two methods, encrypt and decrypt. And in this case, in this solution, I have reused the same algorithm called shift text for both of the encrypt and decrypt methods. since they work in the same way, but the encrypt shifts letter to the right, you might say, and the decrypt shifts letters to the left in the alphabet. So they work almost in the same way. The only difference is this shift amount, which could be positive or negative. And it will be negative for when decrypting and positive when encrypting. Okay, let's look at the shift text method. It takes the shift amount, which could be 3, for example, when encrypting, and then the text, which comes from here. And it starts by creating a so-called string builder to keep the resulting message, which we will build in this loop. And the loop, and this, you have all done something like this. You have created a loop where you have iterated the text using the char array, using a char array. And then there are plenty of ways to do this, but this is just one way. I have tested the case of each character in this loop. And if it is an uppercase letter, that is, then I have shifted the character using the plus and minus, the plus operator to shift, and you received a hint telling you that you could work with characters as with numbers. So you can work with plus and minus as the characters really are numbers. And so you add the amount to shift to the character, but you need to subtract the base character in order to keep this expression from 0 to 25. Otherwise, it's harder, at least, to check that you keep to check these boundaries. That if you go over Z, that you should come to A, and vice versa. If you shift to the left when decrypting and you have an A, and you shift one step to the left, you should come to Z. So in order to be able to use this modulo operator, which does an integer division and gets you the remainder. In order to use that operator, you need to subtract the base character number, which is capital A if the character we're looking at right now is an uppercase, and will be a lowercase a if the character we are looking at right now is a lowercase number or lowercase letter. So most of you have done something like this, and when you have shifted the character to the right position, then you append it to this string builder. And in this case, if it is neither an uppercase or a lowercase letter, meaning that it is actually a non-letter character, then I will add it as is without doing anything about it. So this handles all special characters like space, exclamation mark, question mark, dot, period, and so forth, comma. So this is a way of handling all types of letters, the uppercase letters, the lowercase, and the non-letters. And eventually, when I'm done, I just return the string builder result as a string using toString back to the caller. And let us look in the main method, or the main class and its main method. Here we are creating two variables holding the different ciphers. And this is also a place where a majority, I think, of you did not follow the instructions properly. You were supposed to create variables of the cipher type. Most of you created variables using either the shift cipher or the replacement cipher types. And this, if you do that, your application or your handling of the different cipher types becomes less efficient. I will show you some examples later on. How this is, why that I think will show you why this is important. But first, let us proceed here. These lines here shows you, and this was actually one of the bonus tasks. They show you how to receive data from the command line. So for example, if you start this application from the command line by typing Java and then sc.hkr.cipher.main, and then you supply some command line arguments, like in this case you can supply a number which will be interpreted as the shift amount, and then you can supply the replacement alphabet as a second argument. And we use this args array here. args0 is the first argument, and args1 is the second argument used when starting the application from the command line. And you could also set these command line arguments in IntelliJ when you start this application. I think you do it somewhere around here. Program arguments here. Here you can supply some arguments like this. Okay, that is the way to do that. But if you did not supply any command line arguments, I would just initialize the different ciphers manually here, or give them hard-coded values rather. A shift amount of three, and this is the replacement alphabet. And then I use these objects to call the encryption, or the encrypt and the decrypt methods later on. I think that is it. I want to show you just the importance of using the cipher interface as the type of these ciphers. It is not very clear here why that is important. Most of you, when when discussing the importance of the interface, you said something about that it is used as a contract. It is used to enforce that each cipher has these two methods, encrypt and decrypt, and that is correct. But the most important thing using the Cipher interface is to enable the application to treat all different kinds of ciphers as one type, as cipher types. For example, you could have a method down here, static void encrypt, or call it encrypt, using a cipher and cipher, or call it cipher. Yes, let's call it cipher. And then a message, which is a string. If you have that method, you could then do like this. And perhaps we could just receive this encrypted message encrypted and print it out here. Encrypted. Something like this. This means this method is not aware of what type of cipher object it is receiving. It just knows that it will receive any cipher type. So this method is it can handle any type, any cipher type. And that is the main purpose of using interfaces, that you can treat all the different cipher types as just a cipher object using the type cipher. So you could now proceed with implementing new cipher types, but all the functionality in the application that is using the cipher type will work as previously. They will not need to be changed. They will need to be changed if you use the concrete classes like the shift cipher class or the replacement cipher classes. If you use those types all over your application, and of course, if you then add new classes, you will need to change your code or add some new code to handle these new classes. But if you use the cipher type, you don't need to do that. Okay, I think that's it. I will not walk through the replacement cipher. You will find the source code for both of the assignments on Canvas. Thank you.